Hello guys, this is Garv here, and today I am back with my second video. I have two more questions on the topic of numbers, so let's get started. The figure below shows two stacks of identical bowls. The height of the first stack of 3 bowls is 9 cm, and the height of the second stack of 7 bowls is 17 cm. Find the height of one bowl. So let's get started with annotating the question. We know that the first stack of 3 bowls is 9 cm and the second stack of 7 bowls is 17 cm, right? So to solve this, let's go about by the modular method. So if I draw it out, we have the first stack, right? So we have one long bar followed by a series of two small bars, and for the second stack we have again a long bar followed by a sequence of 6 smaller bars. So one large bar, or rather this large bar, represents the full height of one bowl, and one small bar over here represents the smaller height of the bowl, this height. So the question states that the length of this 3 stack of bowls is 9 cm and the length of this 7 stack of bowls is 17 cm, right? So this means that the remaining smaller stack of 4 bowls, which is just 1, 2, 3, 4, from here to here, this length is this value. So let's represent this by a U, 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 U. So this means that 4U, 4 units, is equals to 17 minus 9 cm, which gives us 8 cm. This is 4U. So this implies that 1U would be 8 divided by 4, which gives us 2 cm, right? So if I just draw it out, this is 2, 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 and this is 2. So now we have to find the length of this whole, we have to find the height of one complete bowl, right? So now if you look at the first model for the first stack, the length of 2 smaller bars would be 4 cm. So this means that the length, sorry, not the height of one bowl would be equals to 9 minus 4, which gives us 5 cm. So the height of one bowl, this height, is 5 cm. Yep. So that's your answer. Now of course there's also another method to solve this question by using algebra. So let me just clear this. Yep. Okay, so what you can do is you can assign the height of one smaller we can assign the height of a smaller bowl as x cm and the complete height of the bowl as y cm. So based on this, we know that the height on the first stack would be equal to y plus 2x cm. and the height of the second stack would be y, and if x, 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 and x. Y plus 6x centimeters, right? So we know that y plus 2x centimeters is equals to 9 centimeters, and y plus 6x centimeters is equals to 17 centimeters. So if we subtract both of these equations, we get 4x centimeters is equals to 17 minus 9, which gives us 8 centimeters. So this leaves us with x centimeters as 8 divided by 4, which gives us 2 centimeters. So now we know that x is equals to 2. Now if we substitute this back into this equation over here, we get y plus 2 times 2 is equals to 9. So then we simplify this and you get y plus 4 is equals to 9. So this means that y is equals to 5. And what is y? Y is the complete height of one bowl. So there you go. Using algebra, you find out that the height of one bowl is 5 centimeters. John had 1.5 meters of copper wire. He cut some of the wire to bend it into a shape as shown in the figure below. In the figure, there are 6 equilateral triangles and the length of xy is equals to 19 cm. How much of the copper wire was left over? So, we know that the length of xy is equals to 19 centimeters, right? And these are 6 equilateral triangles, which means that if I break this figure up into 3 smaller figures, you would observe that xy constitutes of 3 bases of different equilateral triangles. We have one base over here, and the second base over here, and we have the third base over here, right? So now let's assume that the length of the largest base is a centimeters, the length of the medium sized base is b centimeters, and the length of the smallest base is c centimeters. So based on this, we know that a plus b plus c is equals to 19. And now since this figure is made up of 6 equilateral triangles, we know that the sides of the largest triangle are a and a, the medium sized triangle are b, and the sides of the smallest triangle are c. So if we find the total length of the copper wire used, we have a, this, plus a, plus b, plus b, plus c, plus c. This is for one side of the figure, and since the same length of the copper wire is being used on the other side, we can just multiply the value we obtained for this times 2. So if I break this up and simplify it, we have a plus b plus c plus a plus b plus c, and this whole thing times 2, because we have two sides. We have one side over here, and the other side over here, right? So a plus b plus c is 19 as found over here, plus 19 times 2. And what is this? We get 38 times 2, which gives us 76. And now the important thing is, we must not forget the copper wire used for the inner bases of the triangle. So we have 76 centimeters. The perimeter is equals to 76 centimeters, right? And the inner length, or rather the length of xy, is equal to 19 cm. So it means the total length of copper wire used is equal to 76 plus 19, which is 95 centimeters. Right? So now the question says that he had 1.5 meters of wire, right, which is equals to 150 centimeters, and he used 95 centimeters. So this means that he has a total of 150 minus 95 centimeters. He has a total of 150 minus 95 centimeters of wire unused, which gives us 55 centimeters. So therefore he has 55 centimeters of wire unused. Yep. So your answer is 55 centimeters. So those were the two questions for this video. I hope you guys found them helpful. If you have any doubts or any questions, feel free to put them in the comment section and I will do my best to answer them. Yeah, don't forget to subscribe to my channel. Hit the bell icon for notifications whenever I post a new video, and do press the like button and share the videos. Thank you.